Good morning everyone. We are from group 6 and my group members are Rahini, Wang Hihui and I'm Mahalakshmi Vedikaran, and today we are going to present about heat exchanger process. First I would like to explain about case study. The case study is showed that milk is a very nutritious food, but the thing is it has a very short lifetime, and we have to extend the lifetime of the milk, we have to use the method which is known as pasteurization. Next, pasteurization. Now I would like to define about pasteurization. Pasteurization is used to extend the usable life of milk and reduces the number of possible pathogenic microorganisms. It's a process of heat exchange. Next I would like to explain about the graph. In the graph you can see the blue mark and the red color mark. Actually the red color mark shows the hot water, the flow of the hot water, and the blue mark, it shows the flow of the milk. So in the hot water will transfer the heat to the milk that is being flowed over in this blue color tube. That's all. Next, these are the things that we will be using. These are the sample heat exchangers. Actually, the sample heat exchangers are plate type heat exchanger, shell and tube heat exchanger, fin type heat exchanger, and double pipe heat exchanger. And reasons why we have to use heat exchanger is it's easy in constructions and can handle slurries, can be used at low transfer areas, cheap, easy cleaning, and concurrent and counter current can be adjusted easily. Next. Okay, definition of heat exchanger. So now only I am going to define about the heat exchanger. Heat exchanger is something that can transfer from a hot to cold fluid. Heat that can be transferred from hot to cold fluid. The function of heat exchanger. It's directly fired by a combustion process. It becomes a furnace, boiler, heater, tube till, heater and engine. Okay, and it is also used to transfer and useful elimination to recovery heat without change in phase. Next is about the application of heat exchanger. That in two ways we can use the heat exchanger. First in vehicle, second in the laboratory. In vehicle we will use in the engine, as you all know. First in engine we will use to heat up. Then after the engine had heat up more, then we will use a coolant heat exchanger to cool down the temperature of the engine. The next is laboratory. Laboratory we will use for the process for vaporization. It's like a cooler vapor to cause it to condense the liquid. Then after that the vapor is flowed in condenser, which cooled by cold water, and the vapor is condensed to the liquid. Okay, next I pass to safety features. Okay, now I pass to Yihui.
Okay. Thank you, Maha. Now I will talk about the safety feature of our double pipe heat exchanger. First, we have four structures which contribute to this the whole system safety. First is thermocouple. The function of thermocouple is used to record temperature. We have 6 thermocouple. Later we will explain in our prototype. Second is the sensor. Sensor is to detect leakage of the milk. If there is any leakage, the sensor will detect and the system will give alert to the who control the system. And valve is to control direction, make sure it's flow in one direction so that both are counter current, and also to control the flow rate. And the fourth one is flow meter. Flow meter not just to take data, the flow rate is also a safety feature to make sure that the system does not exceed the limit. And next is the benefit of using stainless steel. We choose stainless steel as our material for the double pipe heat exchanger. The first benefit is it is resist to corrosion, because as we know, milk there is also acidic, and water when we use long time it will corrupt the material that carry it. And also The second one is high temperature resistance to oxidation and scaling. Means our milk will process in 72 degrees Celsius and also low temperature to 4, and this will cause, if we use usual PVC pipe, it will corrode faster. If we use stainless steel, we can last longer. And stainless steel also have good strength characteristic in low and high temperature service. It's like similar to the second one. And the fourth one maintains excellent heat transfer property in service. It can exchange heat faster, means it conduct heat faster. Okay, so and for the fifth benefit is no contamination in products. Means it is quite inert. It does not react with the components flows through it, like the milk. It does not have reaction with it. And the sixth one is fabricability. And lastly is economical in terms of cost and service. Although it's quite expensive compared to PVC, but since it can last longer, so the time to do maintenance will be longer, so we need not to buy so frequently the stainless steel. And next I will pass to Rahini to talk about the calculation and stimulation.
Thank you, Yigui. Okay, now I'll explain about the calculation that we did. Okay, actually in doing this heat transfer exchanger, we use the NTU method. NTU method, okay, what do we assume is that the steady operation condition must exist and the heat exchanger must be well insulated, so heat loss to the surrounding is negligible, and the kinetic and potential energy of the fluid streams are negligible. And for the heat transfer coefficient, we assumed that the value is the same to be water to water instead of water to milk, because we assume that milk have the same properties, almost the same properties as water. Okay, next. Okay, so from table we can take the heat coefficient heat exchanger, the U value. Okay, and then we have assumed that the temperature will be 65 and the outlet temperature will be 75 and the system temperature will be 72. So by performing the calculation, we get that the Q max, which is the heat produced, is 50.24 kilowatt. So at the end of the day, actually what we want to find using this calculation is the length. So we got next. So the length we got by using all the formulas is 174 meters, 174 meters. This is what we got from our calculation. So by stimulation, we got that we had this table shows that I have manipulated the length and the diameter. I manipulated the length and find out what is the diameter. So I assume that the length is 150 and the diameter will be 0.0175. When I decrease the length of the pipe, we can see that the diameter increases. So if we want a shorter length of pipe, we need a bigger diameter. So by using this equation, D equals to A over pi L, we have stimulated this data. Okay, for the next table, for the next explanation, we have used the L over D ratio as 100 over 0.026 because by referring to many literature reviews and research, we have found out that 100 over 0.026 is the perfect L over D ratio. Okay, this is actually usually the NTU ratio is larger than 3, but but it's not economically applicable. Therefore, we use L over D ratio as 100 over 0.026. Okay, next. Okay, next, this is the AutoCAD drawing. I'll pass to my friend.
So this is our AutoCAD 2D drawings. We show that we have 5 parts of horizontal, means 1, 2, 3, 4, 5, and each part is 19.8 meters, and plus 0.25 vertical, we have 4 parts. So 0.25, we have 4 parts, means 1 meter, and total is 100 meter. And the diameter we use for the inner one is 0.026 as calculated. And for this circle part is the thermocouple, which I mentioned in safety feature to detect the temperature change. And this square part is the flow meter to measure flow rate and also to prevent it exceed the system limits. And so this is our prototype. We make this using straw and also fruit sticks. This is quite similar to our drawing, and for the dimension we scale down, but we write the actual dimension here, which is 19.8. Okay, and so this is our prototype, and that's all from us.
Okay. That's all from us. Thank you.
Thank you. Bye bye.